Hi and welcome back to MDriven. I'm gonna do a commentary of a video that I saw. It started with me doing this LinkedIn post that magic is the opposite of engineering. And then that making it work is a great start, but it isn't the finish line. So it's sort of my critique against all quick fixes with the vibe coding and using AI, because I wouldn't say that that's engineering. That's more like the magic. And please do consider to follow me on LinkedIn. So on LinkedIn, I'm Hans Karlsen, Sweden, or you can also find me at MDriven, of course. And the video that caught my attention was this one. Coding is not equal to engineering. And that's more or less the same area which I alluded to in my LinkedIn post. I was intrigued, so I watched the video. So the person being interviewed here is Jeremy Howard, and he's the founder of something called fast.ai. So I'm gonna take some excerpts from this video and reflect over them. And of course, if you find this subject interesting as well, you should watch the whole video, because I will not cover all the pieces, just the things that stuck out to me. So let's just start it, and then I will skip ahead and find some interesting sections.
It literally disgusts me. Like, I literally think it's inhumane. My mission remains the same as it has been for like 20 years, which is to stop people working like this.
Jeremy Howard, a deep learning pioneer, a Kaggle grandmaster. He is a huge advocate for actually understanding what we are building through an interactive loop, a notebook, a REPL, the act of poking at a problem until it pushes back. He argues this is where the real insight happens.
And the funny thing is, they're both right.
So, just my first reflection on that is that I totally agree. Poking at the problem is where the knowledge actually comes from. Anyone can have a problem statement, but a problem solution always requires, in my experience, a deep dive into the problem subject matter. And it's it would be fantastic if we didn't have to do it, but then who understands it? And there is a value in understanding it. So even if we could, in theory, hand it over to someone else, then we are a bit of a slave to someone else. So we see this. This is seldom good for business to not own your own stuff. And while you poke at the problem, as in here he talks about notebooks, and if you substitute notebook to MDriven designer, you have a model where you change continuously and see the effects in the running enterprise system, like with live edit. So we're not, the metaphors are not million miles apart. It's quite close, but maybe we can learn something more about how a notebook strategy should be put up in the MDriven designer to even further make it apparent that what you're doing is actually deep diving and learning about the problem while you solve the problem.
Like, that's all it did, which is impressive. And I'm much less familiar with math than I am computer science, but from talking to mathematicians, they tell me that that's also what's happening with like ERDOS problems and stuff. It's some of them are newly solved, but they are not sparks of insight. they're solving ones that you can solve by mashing up together very closely related things that humans have already figured out.
So on the subject of Claude Code, now I know you've spoken extensively about vibe coding. Actually, Rachel had some interesting work out. I mean, she quoted the Meta study, which showed that productivity actually went down when people were vibe coding. But I think,
and they thought that they went up, which is the most interesting bit.
Well, yeah, and then also there was the Anthropic study. I mean, maybe we should rewind a little bit. I mean, Dario had this essay out the other day. I think it was called "The Adolescence of Technology" or something like that. And he was basically saying, look, we have all of these amazing software engineers at Anthropic, and they are just so productive. And he was extrapolating to the average software engineer. So there's going to be mass unemployment because soon we're going to be able to automate all of this with AI.
I mean, it doesn't make any sense. Elon Musk said something a bit similar a few days ago, saying like, oh, LLMs will just spit out the machine code directly. We won't need libraries, programming languages.
Yeah.
Yeah, look, the thing is, none of these guys have been software engineers recently. I'm not sure Dario's ever been a software engineer at all. Software engineering is a unusual discipline, and a lot of people mistake it for being the same as typing code into an IDE. Coding is another one of these style transfer problems. You take a specification of the problem to solve, and you can use your compositional creativity to find the parts of the training data which interpolated between them solve that problem, and interpolate that with syntax of the target language, and you get code. There's a very famous essay by Fred Brooks written many decades ago, No Silver Bullet, in which it almost sounded like he was talking about today. He was specifically saying something, he was responding to something very similar, which is in those days it was all like, oh, what about all these new fourth generation languages and stuff like that? We're not going to need any coders anymore, any software engineers anymore, because software is now so easy to write, anybody can write it. And he said, well, he guessed that you could get at maximum a 30% improvement. He specifically said a 30% improvement in the next decade, but I don't think he needed to limit it that much, because the vast majority of work in software engineering isn't typing in the code.
Yeah.
So in some sense...
Yeah, so, and that's a very important point that I guess many people not experienced with software development doesn't know that typing speed has nothing to do with solving problems. And that's obvious to anyone of us that actually work in this field, but it's hard to convey well then what is the essence of solving a problem if it's not typing the code faster. So this is back to his notion about wrestling with the specific problem back and forth to see how it reacts to poking. So this might be a good paper to actually read, No Silver Bullet, Essence and Accidentals of Software Engineering, and the critique against different approaches, because if the approach only speed up the way you feed in code, essentially, then we have a problem. So what MDriven does is partly speeding up things, since you don't need to type code for a class or persistence of specific attributes or associations. But the main win with the strategy of MDriven is that you build the model that's available for you, which is easily accessible to your brain. So you can come back to it and see all the things that you solved, albeit fast, but that you solved a week ago or yesterday. And that's really the essence to that none of the other strategies that we see to vibe coding actually delivers on. They deliver on the fast part, but they do not deliver on understanding what you actually did part. And to understand what you actually did is crucial for adapting your solution to better fit the problem. And so it's a problem solving domain more than a coding domain. And since we introduced LLMs to skip to so that we can have code faster, doesn't actually address the problem solving part of it. If you're solving a problem that has been solved before, so that it for certain is in the training data that your LLM has, then you can benefit from it pulling that training data up and showing you that this is a solution that has been done before, and that's fine. And that's speed, and that's progress and an increase in productivity. But a real life problem that you're put to solve usually isn't a problem that has been solved before. It's usually some novel aspects to it, and that's why they called you. And since the novel aspects are sprinkled around the problem domain, you don't really know where they are. But this is where AI can really help you to pinpoint that this is a known problem, and that's usually solved this way. What we call best practices or etc. That's really good that we can get instant access to the world's library of best practices and solutions, and we can get that code really fast, or in MDriven's case, that model section really fast, and that's good. But the novelty of the problem, you really need to poke it until some creative brain, most likely your own, find a way to get past that particular problem. And why it's somewhat important that it's your brain that gets past that problem and not the AI that gets past that problem is because there will be more novel problems after this, and you need to tag along to know. You need to know what you have solved before and what you're going and what the new problem is that you should solve next. And if someone else is doing the homework for you, you're sort of lost when it comes to the test. It's always better to be in control. At least that's my way of looking at understanding. And that's whom we design MDriven for. A way to stay in control and really own your definition and your problem solution. And I can also say that what Jeremy says here, and which I agree upon, is that AI sort of mishmashes the solution from the training data, because it picks parts that it recognizes, that concepts that it puts together, and maybe it translates it into a new language that you are looking for, and that's might be good. But what we do differently at MDriven is that we just don't guess based on Bayesian distribution, but in MDriven we force you to declare precision. And if you declare precision, you don't need to be that worried about if there are edge cases within the guessing. You will know exactly what the road leads to in a different way than a lot of Bayesian guessing. Because at the end of the day, you have rolled the dice 1,000 times to get the response out from the AI. And that would probably be different if you try to redo it. But if you really think and know what you want to do, it will probably most likely be almost the same if you for some reason need to redo it, which is that solution lends itself to more determinism, that you actually know the solution space it's gonna act in a total different way than you can assume that you know if you had someone else do it for you.
Marvita Chiramuta, she's a philosopher of neuroscience, and she was talking all about, basically that knowledge is protean. So yeah, I think that knowledge is perspectival. I don't think that knowledge can be this abstract perspective-free thing that can exist on Wikipedia. And I also think that knowledge is embodied and it's alive. It's something that exists in us. And the purpose of an organization is to preserve and evolve knowledge. So when you start delegating cognitive tasks to language models, you actually have this weird paradoxical effect that you erode the knowledge inside the organization.
This is super interesting and really important, I think. You erode the knowledge within the organization. And that's the effect of automated abstraction with AIs, that we sort of skip the hard thinking, and by doing that we also skip stuff that we would have learned if we were forced to do the hard thinking. And maybe it's important that we learn and know what we're doing and what we need to do and what we have done. Maybe that's crucial in order to actually be creative in the next step. Because if we know what we're doing, as we do with the models, when we force you to declare actually what you want to do, not just spoon feed you some distribution from the internet, that builds your stamina and resilience to competition.
Oh, that's true. And that's terrifying. There's often these arguments online between people who are like, LLMs don't understand anything. They're just pretending to understand. Mm-hmm. And then other people are like, don't be ridiculous. Look what this LLM just did for me, right? And the funny thing is they're both right. LLMs cosplay understanding things. They pretend to understand things. And this was the interesting thing about the early kind of work with cognitive science work with Daniel Dennett. That's basically what the Chinese room experiment is, right? It is, you've got a guy in a room who can't speak Chinese at all, but he sure looks like he does because you can feed him questions and he gives you back answers, but all he's actually doing is looking up things in a huge array of books or machines or whatever. The difference between pretending to be intelligent and actually being intelligent is entirely unimportant as long as you're in the region in which the pretense is actually effective, So it's actually fine for a great many tasks that LLMs only pretend to be intelligent, because
So I agree, as long as you're within a known problem space, things that have been solved before, and you get results from the LLM and from the AI, that's super fine. You should use it. But the problem space, the space of possible problems, is humongous. And I think most people underestimate that the border to the unknown is almost eternal in size, and it's most definitely growing, because whenever we make a new discovery and learn something, it's not that we reduce that border. We have actually opened up a new door which has even more new unknown possibilities behind it. So everything is always growing when it comes to problem solving and the tools available to us in problem solving. So we can't assume that we can sit back and just sort of think that since the LLM read the internet year 2026, all is known. Or things, there will be no new things that we need to address because it has already been seen. And this is, in my view, fundamentally flawed thinking. That's not how the world works. There's always one more thing, one more nuance, one more aspect, one level deeper of abstractions, and getting closer to some ideal description of the world. It will most likely never ever stop.
For all intents and purposes, it just doesn't matter until you get to the point where it can't pretend anymore, and then you realize, like, oh my god, this thing's so stupid.
I'm a fan of Searle, by the way. So, he said that understanding is causally reducible but ontologically irreducible, and he was saying there was a phenomenal component to understanding, but you don't even need to go there. Like, the interesting thing about knowledge being protean is this idea that it's basically this Kantian idea: the world is a complex place, none of us understand it. It's like the blind man and the elephant. We all have different perspectives. It's a very complex thing, and so we all do this kind of modeling. But the interesting thing is that the language models, sometimes they seem to understand, and they understand because the supervisor places them in a frame. So inside that frame, so when you have that perspective of the elephants, they're actually surprisingly coherent, but we discount the supervisor placing the models in that frame.
Yeah. So Searle versus Dennett, or is it versus Searle and Dennett, was what everybody was talking about back when I was doing my undergrad in philosophy. So I think Consciousness Explained came out about then, probably Chinese Room a little bit before. And it's interesting because the discussions were the same discussions we're having now, but they've gone from being abstract discussions to being real discussions. It's helpful if people go back to the abstract discussions because it helps you get out of your, it's very distracting at the moment to look at something that's cosplaying intelligence so well and go back to the fundamental question.
So this is, I think, very good advice, that we are easily blinded by some really cool examples of an LLM feeding us something that looks brilliant. And we assume that since it could do that, which it could because it was trained on data that looked like that and a problem like that looked like that, we assume that it also can do other type of problem solving of totally novel problems that we haven't really understood ourselves yet. And even if it could, even if it can, my point is that we still also need to understand it. We can't just skip forward to the solution, because we need to understand what goes into the solution in order to be effective to formulate the next type of problem solving need after that. And doing that, the only way I see that, or of course, you can have a gigantic memory, and most people that are good in software development have very, very good memory. So what they do is sort of expand the code base within their head, and then they look that through as an object graph of all the facts and rules that are in their system, and then they can take things further from that. But there's a limitation to that, because there's time. It's really hard work to keep that mental model of a really complex thing inside your head for a very long time. And what this leads to is that after 3 years, most big, large information systems are rewritten, because the good people within the company lose track of what we have. And the solution to that is to reduce the complexity to get the solution. And a very good way to reduce the complexity to get the solution from software is to only keep the model of the information and all the rules expressed in terminology of the model. And that's what MDriven does, and it stacks all that in the MDriven designer and the MDriven model, and that really helps you to shift it out from your head and into your head when you need it. And this is as I see it, the major hurdle to create long-term complex rule systems that stay coherent and that you own and can control over long periods of time. And also that you can shift in and out people in a completely different way than what you usually can do with code alone. And this is an interesting part where he alludes to what happens to companies that fill up their code base with AI generated code, which actually isn't in anyone's head. So there's no software developer that can take that into their head and spin it. Of course, they can put it into the AI's head and let that spin it, but then we have abdicated to actually own the problem, and the AI owns the problem and the problem understanding. Let's listen.
John Osterhout, the TCL guy, recently released some of his Stanford Friday takeaway lectures, and he has this nice one called "A Little Bit of Slope Makes Up for a Lot of Intercept," which is basically the idea that in your life, if you can focus on doing things that cause you to grow faster, it's way better than focusing on the things that you're already good at, that has that high intercept. So the only thing I really care about, and I think is the only thing that matters for my company, is that my team focusing on their slope. If you focus on just driving out results at the limit of whatever AI can do right now, you're only caring about the intercept, So I think it's basically a path to obsolescence through both the company and the people who are in it. And so I'm really surprised how many executives of big companies are pushing this now, because it feels like if they're wrong, which they probably are, and they have no way to tell if they are because this is an area they're not at all familiar with, they never learned it in their MBAs, they're basically setting up their companies to be destroyed.
So what he's saying is that if we only take this easy road and only fill out our repositories with generated code from AI and haven't actually forced our engineers to engineer anything, haven't forced them to grow and to learn the problem domains, that will pretty soon kill the companies, and they will not be able to compete. And what he also says is that the managers of these companies doesn't understand this, because they have the misconception that it's all about production speed, and it's actually about problem knowledge. But that's not something that they have learned in their school when they took their MBAs.
And really surprised that, shareholders would let them do that, set up such an incredibly speculative action.
And I tell Claude Code, go and do this thing. And the model's in my mind, doesn't matter. And then you go into an organization, and now I need to share like my knowledge with all of the other people, right? And I'm sure you have this in your company as well. Like you need to, this knowledge acquisition bottleneck is a real serious problem in organizations. So when it's just me, I think I'm probably about 50 times more productive using Claude Code. It's absolutely magic. And I can see why people are so excited about it. But people don't seem to understand the bottleneck and how that doesn't really translate to many real world organizations.
No one's actually creating 50 times more high quality software than they were before. So we've actually just done a study of this, and there's a tiny uptick in what people are actually shipping. That's the facts. Obviously, I'm an enthusiast of AI and what it can do, but also my wife Rachel recently pointed out in an article, all of the pieces that make gambling addictive are present in
dark flow.
Yeah,
I was going to bring that up. Yeah, tell us about
coding.
That. Yeah,
it's this really awkward situation where it's almost everybody I know who got very enthusiastic about AI powered coding in recent months have totally changed their mind about it when they finally went back and looked at like how much stuff that I built during those days of great enthusiasm am I using today? Are my customers using today? Am I making money from today?
Yeah. So this is very good stuff, and totally aligned with my feelings and my thoughts in this area, that problem solving that is done fast might not actually be solving anything. Of course, I will not be able to convince anyone of that, as he states here, that all the components of gambling are present in this work model. So it's extremely addictive and instant gratification and everything like that. So you're in a loop, and you're fascinated about your superpowers. But you can't live on sugar alone. Or you shouldn't. It isn't good for you. So I really must stress the importance, and also what he alludes to is the problem. He said briefly here that the model is in my head, and when it's only me, I'm very much productive with Claude Code. And that's interesting. The model is in my head. That was what I said just now, that any good software developer have a mental model of the code base. And if you can have that, and if you can remember that, you're very good to explain to others what it is that you are doing, what you want the AI to do, and you can make the AI do the right thing by asking it and asking it and asking it and asking it until it hit that model that you have in your head. And if you need to ask it multiple times, you sort of lose a bit of this productivity gain, of course. If you need to lose it, if you need to ask it 10 times, it could ideally be 10 times faster if you just needed to ask it once. So if you have the perfect model in your head, have you ever considered to note it down in the MDriven designer and then just execute it deterministically? Why would you not do that? So that's the message that MDriven pushes onto the world, and that we build tools for, and that we want to see more people use it.
Almost all the money is being made by influencers, or by the companies that produce the tokens. The thing about AI based coding is that it's like a slot machine in that you have an illusion of control. You can get to craft your prompt and your list of MCPs and your skills and whatever, but in the end you pull the lever, right? You put in the prompt and something comes back and it's like cherry, bzz. It's like, oh, next time I'll change my prompt a bit, I'll add a bit more context, pull the lever again. It's the stochastic thing. You get the occasional win that's like, oh, I won, I got a feature. So it's got all these hallmarks of like loss disguised as a win, somewhat stochastic, feeling of control, all the stuff that gaming companies try to engineer into their gaming rooms. Now, none of that means that AI is not useful, but gosh, it's hard to tell.
I know, and Rachel, just to be clear as well, she also said that one of the hallmarks of gambling is that you kind of delude yourself that you have some awareness of what's going on, but actually you don't. But let's do the bull case a little bit though. So because I do think in restricted cases it is very useful, and these are cases where we understand and we can place constraints and specification. But even in those cases, you could argue on the one hand that we're not going to be unemployed anytime soon because you just do more work. On the addiction thing, I've noticed that. So I've had 14-hour Claude Code marathon sessions, and I actually feel addicted to it. It's like a slot machine. It really is.
In there too, absolutely.
Yeah. Okay. Do you want to sit 14 hours having the perfect model in your head, just pulling the lever, trying to get the AI to deliver on what you have in your head? Is that or do you want to pay personnel to do that? And even if they get the win and they have the perfect outcome, the knowledge that they have in their head, that they pull the lever and stop to pull the lever as soon as the system delivered on that knowledge, that's only in their head, right? And then in the code that the AI generated. But is that something that you want your other developers to try to reverse, to understand the problem from the first guy that actually had solved the problem in the head? So all this about having stuff in your head, it doesn't scale. You should use pen and paper or MDriven designer. Do UML models that are deterministic and without alternative interpretations. And it might not be as easy as pulling a lever, but it really evolves your way of thinking about the problem at hand. You really get into the problem. And of course it can be tiresome to solve complex problems with your brains, and most likely more tiresome than pulling a lever. But on the other hand, if you need to pull the lever 14 hours, I can promise you that putting the work in, you will be done in 1 hour or half an hour using MDriven. So that's also a big difference. And you will have the documentation forevermore, so that you can actually swap it out of your head, swap it back in, and change a few things, and extend in another way than just putting it into a slot machine again and pulling a lever.
Yeah, I know it's, and it just I've never felt more drained writing code. I actually need to take a rest afterwards, like a few days rest, because it completely
It feels
kills
like crap, Yeah, definitely. I've had some successes, right? And so, in fact, we've spent the last couple of years building a whole product based around where we know the successes are going to be, which is when you're working on reasonably small pieces that you can fully understand and that you can design, and you can build up your own layers of abstraction to create things that are bigger than the parts that you're building out of. Had a very interesting situation recently where it was kind of an experiment basically, which is we rely very heavily on something called IPyKernel, which is the thing that powers Jupyter notebooks. And there'd been a major version release of IPyKernel from 6 to 7, and it stopped working. And it stopped working in both of the products that we were trying to use it with. One was called today NB Classic, which is the original Jupyter notebook. And then it's our own product called Solve It. It would just randomly crash. And IPyKernel's over 5,000 lines of code. It's very complex code, multiple threads, events, blocks, interfaces with IPython, with ZMQ, all kinds of different pieces, debug and I couldn't get my head around it, and I couldn't see why it was crashing. The tests are all passing. I wonder if AI can solve this. It's like I'm always interested in the question of like how big a chunk can AI handle on its own right now. The answer turned out to be yes. I think it can just. It was like, so I spent a couple of weeks. I didn't develop a lot of understanding about how IPyKernel really worked in the process, but I did spend quite a bit of time kind of pulling out separate, so the answer was in 2 hours, codex 5 point, I think it was 5.2 at that time, or maybe 3 had just come out, couldn't do it. Then if I got the $200 a month GPT 5.3 Pro to fix the problems, it could. And so by rolling back between those two pieces of software and those two models, I could get things working over a couple of weeks period. And like you say, it wasn't at all fun. It was very tiring, and it felt stressful because I wasn't really in control.
So I wasn't really in control. It felt stressful. That's not the way you should feel when you ship software. Maybe it's the way that many people actually feel when they ship software, but it shouldn't be like that. That's a indication that you're doing something wrong. You're not in control. You should be in control. You should own your things.
But the interesting thing is I now am in a situation where I have the only implementation of a Python Jupyter kernel that actually works correctly, as far as I can tell, with these new version 7 protocol improvements. And now I'm like, well, this is fascinating because we don't have a kind of a software engineering theory of what to do now. Like, here's a piece of code that no one understands.
Yeah.
Am I going to bet my company's product on it? And the answer is I don't know, because like I don't like I don't know what to do now, because
So this is the returning problem of what was it called? The Boeing Max 8 or something like that. There was a lot of code. No one really knew what the code did, and some of the planes crashed. Of course, they blamed the sensor on the outside, but the sensor didn't push the rudder in the ground. It was the software that got the mixed message from the sensor that did that. And the Toyota cars where the gas pedal just froze and drove into concrete walls. Of course, it wasn't the gas problem that was the problem. It was the software. Determinism in software will be more important as we build more complex software. Of course, one can argue that there will be no 100% determinism, but if we have the strategy that our software adheres to exactly this declarative model that we do understand, then it's much better than if we have the strategy that I pull the lever 1,000 times and all of a sudden it passed the tests that I set up. So now we ship. Because let's think about what tests are. Tests are error cases that we have either seen or that we expect to see. Okay? But the number of error cases that actually can show up in reality are a lot more than the ones that we expect. Building test-driven development has always, for me, been like trying to take the shit out last. Build whatever you want, and if it passed the tests, then it's okay. That's not engineering. And that's you can do that with random. To actually build quality, you need to understand what you build. You need to have an idea and be fairly comfortable with what you have built. And that's my conviction.
No one's like been in this situation, and like, does it have memory leaks? Will it still work in a year's time if there's some minor change to the protocol? Is there some weird edge case that's going to destroy everything?
Yeah, so I'm gonna leave it here, and I urge you to watch the full video yourself. I think it was fairly this was a good reflection of the state of affairs today, and it's a great motivation for us at MDriven to understand why we do the things that we do, and it should be a great motivation for you to come and see what we do. Thank you.